Hello everyone, in this video tutorial we will explore how to build a deep learning model using FastAI to distinguish between the images of dogs and cats. Okay, so FastAI is a deep learning library which is built on the top of PyTorch. So let's begin with this code. In the first line of code we have from fastai.vision.all import star. So this line of code imports all the necessary um, modules from the FastAI. So here from is a keyword used in the Python for importing specific attributes, and this FastAI dot vision dot all. So this one says this is the module from which the attributes are being imported, and this one FastAI is a deep learning library, and FastAI.vision specifically focuses on computer vision tasks. So okay, so this FastAI is a library, and FastAI.vision specifically focuses on the computer vision tasks. And this import star says, and here star is a wildcard that means import everything. Okay, so this line imports all the attributes, functions, classes, variables from the FastAI.vision.all module. So let me execute. You can type shift enter or use the play button to execute this line. Next line of code is path is equal to untar underscore data urls dot pets. Okay, so here path is a variable that will store the path to the location where this data set is downloaded and extracted. Untar underscore data, this is a function provided by the FastAI library for downloading and extracting datasets. It automatically downloads the dataset from the specified URL if it is not already downloaded, and returns the path to the extracted dataset. And this urls dot pets, this is a predefined constant in the FastAI library that contains the URL for the pets dataset. After executing this line of code, the path variable will contain the path to the directory. This path variable will contain the path to the directory where pets dataset is extracted. We can then use this path to access the dataset files and folders for further processing. Okay, let me execute this line. Shift enter. So I have already downloaded this dataset from the pets, and to see the path where it is downloaded, you can use path.ls. So ls is a method called the path object. So this one will list the contents of the directory represented to the path object. Let me execute. So if you can see, we have the path where our data is downloaded. So it is downloaded in the this path. Let me navigate to that path. If you go to this users hp and then FastAI folder, you can see the data folder, and here we have the data extracted from the pet dataset from auth code, this one. And then if you go here, you have three folders: annotations, images, and models. And if you go here, images folder, we have this many images. We have around 7393 items in this folder downloaded from this line of code. So just by using this line of code, we have downloaded 7393 files of images. And this data set, the file name is starting with capital letter, then we say so those are cats. And if they are starting with a small letter, then they will be classified as dogs. So we will use these images, around 7393 images, to build our model and the train based on this data. Okay, so what we'll say, if file name is starting with a capital letter, then we assign it as a dog, sorry, cat. If it's starting with a small letter, then we will assign it as a dog. Okay, so next line of code we need to write um, to label the images. Okay, before that we'll use this one, files equal to get underscore images underscore files. Okay, so we have downloaded our data set from this, but we need to get the images from this path. So basically we have in this downloaded data, we have many folders, so we need to get the data from the images folder. Okay, so from the path we need to get the images from this images folder. So that's why we're writing this line of code, files equal to get images files path slash images. So this path already contains the path for this downloaded data. So here files is the variable that we are assigning that will store the list of images retrieved by the get images get underscore image underscore files. Okay, let me execute. So now, after executing this line of code, this the files variable will contain a list of file paths corresponding to all the image files found in the images subdirectory of the dataset. Okay. Now we will write one function, label underscore function, um, to classify the images. Okay. So here label underscore function is the name of the function we are defining, and f, this function takes one argument f, which is expected to be string represented a file name or a path. Okay. If f of 0 is upper, this line of code checks if the first character of the file name f, file name or path, is uppercase. Okay. And this method return cat if the first character of the file name is uppercase, else return dog. Okay. If the first letter of the f is upper, then return cat, otherwise return dog. Let me execute this line. Next we have this image data loaders. Here DLS is a variable that will store the image data loaders object created by the from underscore name underscore function. So this image data loaders dot from name underscore function is a method provided by the image data loaders class into the first AI vision module. So it is used to create image data loaders object from image files, where the labels are determined using a custom function label underscore function. So we need to provide the path where the this is the directory path where the image files are located. It's provided as the first argument to the from name underscore function, and then we are providing files. This is the list of image files or the file paths. It is provided as the second argument. Next we have label underscore function. This is the custom function that determines the labels for the image files. It provided as the third argument to this function from name underscore function. So we call all of this as the argument. So first argument is the path, second one is the um, files, which contains the list of image files. So this one is the path for the directory, and this one is the path for the file images. And then label function to classify whether it is a cat or a dog. Okay. And then we are saying item underscore tfms. This is the transformer that resizes the image of each image. So we can do the batch underscore tfms also if you want to resize batch wise. So this item underscore tfms will resize the each image item wise. So these are the four arguments we are providing to this from name underscore function. So let me execute. So now we have created this DLS. So after executing this line of code, DS variable will contain an image loader object that is used to train and validate deep learning model on the specific image data. Okay. So to see the data that is contained in the DLS, we can use show batch. So this method is called on the DLS object. It displays the batch of images along with their corresponding labels that coming from the label underscore function. Okay. Let me execute. Yes. So if you can see here, we have the labels given for each image, dog, cat. Okay. So this dog cat is coming from this label function. Okay. Now that we have data added into the DLS variable, it's time to create learning model. Okay. So learn is a variable that will store the learner object created by the vision underscore learner function. So the learner object is used to train and evaluate deep learning model. So here vision underscore learner, this is a function provided by the FastAI.vision module. It is used to create a learner object for training a computer vision model. So to this module, we are providing three arguments. One is DLS. DLS, as you know, DLS contains the image data loader object that contains the training and validation data sets along with the data loading configurations. So this one is provided as the first argument. Next we have ResNest 34. ResNest 34. This is the pre-trained CNN architecture, convolution neural network CNN, that will be used as a model for this one. So we provide this one as the second argument. Next we have metrics So we are going to get the metrics error rate. So this specifies the evolution metric to be used during the training. So what kind of metric we need? So we need the error rate. In this case, error rate is used as evolution metric, which represents the error rate. So after executing this line of code, we will contain a learner object, that is uh, learner object to be trained on the provided data DLS using the specific model, that is REST 34. This model performance will be evaluated based on the metrics error rate. So basically, for visual learner, we are providing three arguments: DLS, which is the image data loader, and the REST 34, which is the model architecture, and we are evaluating the model based on this metrics error rate. So basically, this metric will help us to evaluate how this model is performing. Okay, let me execute. Okay, next. So now we have this learner variable which contain learner object. Sorry, a learner object. Next, it's time for fine tune. So as you know, this learn is a learn object that represents the model created using vision learner and trained on the data provided by the DLS. Okay, next, learn dot fine tune of one. This method is called on the learner object. The fine tune method is used to tune the pre-trained model on the dataset. So the one argument passed to the fine tune method represents the number of epochs for which the model should be fine tuned. Okay, so let me execute. So here you can see the results of the fine-tuned. You can see the metrics, uh, training loss, validation loss, and the error rate. So error rate is very minimum, that is 0.004. So let's see the results, how the model is predicting. So here learn dot show results. Here, as you know, this learn is a learner object, and this show results is a method on the learner object. It displays the results of the predictions on the batch of validation data. So let me execute. In the metrics, you can see how much time it has taken to run. It depends on the configuration of your system. If your system is having good GPU, then it takes very less time. So after running this code, learn not show results, you can see the prediction, what is the actual and the prediction. So it's almost correct everywhere, because you can see the error rate is very minimum, 0.004. And now let's test with some external image other than from the data set that we have. So I have downloaded a few images from the internet. So I have downloaded these images, 1200 and 1300. Let's load these images and see the output from this model. Okay, for that I'm using from PAL import image. After that we have image.open. Here we are trying to open the image from this path. So image.open is a function provided by the PAL library for opening and loading images. It takes the file path of the image as the input and returns image object. Okay, so if you not have installed any libraries that are used here, you need to install using pip install. Okay, so I have the image downloaded in this downloads folder, but the image file name is 1200.jpg. Okay, now execute. So let's see what is the image it is loading. Let me just zoom out and add one more cell here. So if you can see, I'm going to add image. I'm going to see what is the image that is loaded here in the image variable, and then enter. So we have this image 200 loaded. We don't have any classification here. I just have displayed the image. So we use this learn dot predict. So this learn is the learner object that we have created using this vision underscore learner, where we have given the training model, and so using this learner model, we will use this img, that new image that I have downloaded, to see the results. So now let's print this prediction. What is the prediction? To see the output of this prediction, I'm using print. You can see this one is identified as a dog, which is true. Now let's load another image, which is 1300. Execute. So let's see what is the image in that. So it is a cat. Let's see if our model predicts the cat. So see the output. I will run the again print prediction. So it ran. So the output is cat, which is 100% correct. So I hope this tutorial is helpful to you. I will provide the link for this code in the description. Thank you for watching.